The properties of a hyperbola lend themselves to application problems that involve things like radar or detection systems, as we're going to see in this next example. It says there's a listening station located at point A, and we're going to mark that as coordinates 2200, 0 in feet, and another at B, which is negative 2200, 0. And we have an explosion, and that explosion occurs such that the people at station A hear it 1 second before it's heard at station B. So if we assume that sound travels at 1100 feet per second, then the explosion took place 1100 feet farther from B than it did from A. And the locus of all points that are 1100 feet closer to A than to B is one branch of a hyperbola that has its foci at A and B. So if we wanted to draw this in, we know that there's the distance from A to the explosion, there's the distance from B to the explosion, and because the people at point A hear it 1 second sooner than those at point B, then I know that point B has to be 1100 feet further away from the explosion than A. And so the locus of all points that are 1100 feet closer to A than they are to B would be a hyperbola. So we know that our explosion occurred on the right half of this hyperbola, and so we need to come up with its equation. Since we have our center at the origin and we have our foci on the x-axis, then our general equation would be x squared over a squared minus y squared over b squared equals 1. And then we also know that if we took the distance from B minus the distance from A, that would equal 2A. And we know that this distance is equal to 1100 from the scenario we set up. And that means that A is going to equal 550 feet. So if we go back and substitute that in our equation, we're going to have x squared over 550 squared minus y squared over whatever b squared is equals 1. So to find what our b squared is going to be, we can go back and look at our foci. We know that our foci have the equation c squared equals a squared plus b squared. So c squared would be 2,200 squared, and a squared is 550 squared. And so we can solve for b squared. And when we do that, we take 2,200 squared and subtract 550 squared. We get 4,537,500. And so let's go ahead and square out 550. 302,500. And so we have our equation for our hyperbola that this explosion occurred on somewhere on the right branch.